Welcome to Educator.com. Today we're going to be factoring general trinomials. In previous lessons, we factored trinomials with a leading coefficient of 1. However, today we're going to work with those that have coefficients other than 1. So, suppose ax squared plus bx plus c factors as a product of two binomials. So now we're looking at a more complicated situation. When we had a leading coefficient of 1, we discussed a method for factoring that expression into two binomials. And we want to do the same thing here. However, it's going to take a different approach because we also have to worry about this coefficient of other than 1. When we had a situation where this was the form, leading coefficient of 1, I factored out like this. I knew that I had x here and x here. Now it's more complicated because it's not just x, there's a coefficient in front of these. So I have to not only worry about what b is, what c is, I also have to worry about what a is. Therefore, this is going to take a different, more complex approach, but you just need to follow each step, and the most important thing is to stay organized. Okay, so the approach, if you have a trinomial in this form, is to first write it as a polynomial with 4 terms. Once you've done that, then you can factor it. This is the hard part. The hard part is getting from here to here. So, how do I figure out what m and n are? I want to split, really, bx into mx plus nx. But I need to have the correct m and n. Well, there's a couple of properties that will help me to determine what m and n are. The first is that m plus n equals b. So the sum of m and n equal b. The second property is that the product of m and n equals ac. So the product of m and n is equal to the product of a and c. In order to find what m and n are, we're going to make an organized list. When we factored trinomials with a coefficient of 1, we also made a list based on properties of p and q. We're going to do the same thing here, but working with a different situation. Looking at an example, if I have x squared plus 30x plus 25, that is in this form. I have a leading coefficient that is other than 1. What I want to do is write it as a polynomial in this form with 4 terms. So I know that a equals 8, and I know that b equals 30. Therefore, according to this, m plus n equal b, which equals 30. Okay, I have c equals 25. So that tells me that m times n equals a times c, which equals 8 times 25, which equals 200. Okay, so again, find a, b, and c. Then recall that m plus n equals b, in this case 30. M times n equals a times c, which in this case is 200. Once I know that, I can make my list. I need to look at this 200 and say, okay, I want to find factors of 200. And these are going to be possibilities for m and n. This is going to help me find m and n. Okay. The second thing I know is that the sum of m and n needs to be 30. I want it to equal 30. So I'm going to go ahead and find factors of 200. And I can start out with 1 and 200, but I know that those are much too far apart. And I'm going to end up with 201. I need to find factors that are closer together. So I tried 2 and 100. adding those, I'll get 102. Still not close. 4 and 50. Adding those gives me 54. 5 and 40. Getting there, but not quite. 8 and 25. 10 and 20. And I finally found it. So right now I'm writing more of a comprehensive list starting with 1 and 200 and going on. But as you get more proficient at this, you're going to be able to just zero in on the possibilities that are more likely. So your list won't have to be so long. Okay, so looking at this, only 10 and 20 meet both of my criteria. They have, this M and N would give me a product equal to AC, or 200, and a sum equal to B, which is 30. Now, remember what my goal was. My goal was to write, my first step was to write this trinomial as a polynomial in 4 terms. So I'm going to write this again, ax squared plus 30x plus 25. Now I want to write that in this form. My ax squared is the same. My ax is the same. My c is the same. So my c over here is the same. What's different is this middle term. It's split into these 2 terms. This is m and n. So here I'm going to have m equals 10 and n equals 20. So I'm going to have 10x plus 20x. So again, the overall approach is to write a trinomial in this form as a polynomial in 4 terms. The difficult part is finding m and n, but you just need to use the rules that tell you what the restrictions are on m and n, make an organized list, find the correct pair. Okay, now we still haven't factored it yet. All we've done is turn it into a polynomial in 4 terms. Now recall from previous lessons that when you have a polynomial with 4 terms, you can use grouping to factor. Okay, so I'm going to carry over that example from the last slide, and we're going to continue on, and we're going to factor by grouping. So I started out with 8x squared plus 30x plus 25. Then I turned it into this form, 8x squared plus 10x plus 20x plus 25. Now I'm going to factor by grouping. Recall that when you factor by grouping, you group the first 2 terms and then the second 2 terms. So grouping this, 8x squared plus 10x plus 20x plus 25. After you've grouped those 2 terms, find the greatest common factor of each group. Okay, so I have 2 groups. For my first group, I do have a common factor of 2 for the numbers, and for the variables I have a common factor of x. So I can rewrite this as the greatest common factor times this simpler binomial. So that's going to give me 4x plus 5. For this second group, I have a common factor of, let's see, 5. My common factor is 5. No common factor with a variable. Okay, then remember, I'm going to factor with grouping. This is just a review of factoring by grouping, which we did in a previous lesson, which you can review. Factor out the common binomial. My common binomial is 4x plus 5. So I factored that out, and I have 2x plus 5. Actually, no more, this is just going to be a product now, so no more plus sign. So I started out with this trinomial. When I saw it had a leading coefficient other than 1, I figured out what m and n were so that I could make it a polynomial with 4 terms. Once you get to this point, you just approach it the same way we did previously with polynomials with 4 terms. Group the terms, the first 2 and the second 2. Find the greatest common factor for each group. Then factor out the common binomial. So this is in factored form. And if I had an equation, if this had been an equation, I could have gone on and then solved for x. Here I was just factoring out this expression. Okay, the rules for signs. The rules for signs for trinomials with a leading coefficient other than 1 are the same as the rules for trinomials with a leading coefficient of 1. So if you recall those rules, it says that if b is greater than 0 and c is greater than 0, then m and n are both positive. Okay? If b is less than 0 and c is greater than 0, then m and n are both negative. If c is less than 0, m and n have opposite signs. And if you recall, these are the same rules that we talked about for the trinomials. So as you're factoring, you need to take into account the signs, because you won't always have it in this form. Bx could be negative, c could be negative, they both could be negative. Okay, greatest common factors as applied to this lesson. Before trying to factor a trinomial into 2 binomials, you should factor any greatest common factor out first. And this is actually a general rule with factoring. Today we're talking about factoring a particular type of trinomial, but anytime you're factoring, pull out the greatest common factor first. That way you'll be working with smaller numbers and something that's easier to deal with. Just for example, if you had, say, a trinomial 50x cubed plus 25x squared plus 15x, before you went into the whole method of trying to write this as a polynomial with 4 terms and grouping and all, first notice that you do have a greatest common factor. Looking at the numbers, you have a greatest common factor of 5, and with the variables, there's a greatest common factor of x. So I'm going to pull out that GCF and rewrite this as 5x times 10x squared plus 5x plus 3. Now, this is much easier to work with. So for any type of factoring, first look, if you have a greatest common factor, take it out and then proceed with whatever method that you're using. Now, you may run into a situation where you have a prime polynomial. A polynomial is called prime if it cannot be factored into 2 polynomials with integer coefficients. You can't factor it down anymore. Just as with prime numbers, say 7, you can't break that up into the product of 2 smaller numbers. And it's the same idea with a prime polynomial. You can't factor it down any farther using integer coefficients. So let's say that I was working with this. And from a previous lesson, you recall that this is a trinomial with the leading coefficient of 1. And I do see that I have a negative term here for b and a positive for c. So it's going to be in the form this general form, but when I look at my signs, I see that these signs are actually both negative. Okay. Then I go about it the usual way, where I'm going to make a list, because I realize that P times Q are going to equal C, and C in this case is 32, and the sum of P and Q will be equal to B, which is negative 8. So I find the factors of 32, realizing that I need a sum that is equal to negative 8 if this is going to factor out. So I can start out and I say, okay, they're both negative, so negative 1 times negative 32 would be 32. The sum of that is negative 33. Next, I could try negative 2 and negative 16, factors of 32 that are both negative. Their sum, negative 18, still no luck. Okay, now I'm going to try negative 4 and negative 8. Negative 4 times negative 8 is 32. Still no luck. So I've tried all my possibilities, and none of them meet the conditions that I need to have a P and Q that will allow me to write this in factored form. In this case, I would say that this is a prime polynomial and it's not factorable. So most of the time you're going to be working with problems where you'll be able to factor them, but occasionally you might get a problem. You're following the steps, you made the list, you didn't miss any factors, and it's still not factorable. And in that case, it cannot be factored and it's a prime polynomial. Okay, we will also be working with equations. So today I discussed how to factor expressions in this form. You may also be factoring equations in this form. And again, after factoring is done, no matter what method you use, if you have an equation equal to 0 and you've factored it out, you can use the zero product property in order to solve it. For example, if I had, say, 8x squared plus 30x plus 25 equals 0, I could go ahead and factor using the method that we learned today. And if I did that, I would come up with 2x plus 5 times 4x plus 5. And we will be practicing these in just a minute on the example, but right now just illustrating what to do after you've factored. So you factor and then solve using the zero product property. Now, recall that the zero product property says that A times B, the product of A and B equals 0, then A equals 0 or BSD equals 0. What that allows me to do is write two equations, because either this is 0 or this is 0. And then I can use my usual methods of solving equations in order to solve for x. So not only are we going to be factoring today, but we're also going to be solving equations. Our first example, though, is an expression that we're asked to factor, and it's in this form, this general form. However, we have a negative sign, and I'm going to take that into account as I find my m and n. Remember that A is 12, B is negative 20, and C is 3. Now, m plus n equals B, and m times n equals AC. B equals 12. Therefore, m plus n, the sum is 12, and 3 times, I want A times C, so that's 3 times 12 would give me 36. So I have the product of m and n equals A and C, which equals 36. Actually, correction, m plus n is B. B is negative 20. Okay, so B is negative 20, which equals m plus n, so it's negative 20. The product is 36. Okay, so the other thing I see is that I have b is a negative and c is positive. And what that tells me is that m and n are both negative. And I know that m and n are both negative because b is less than 0 and c is greater than 0. Next, I make my list. My list is going to involve factors of 36. So these are possibilities for m and n that give me a product of 36. They're both going to be negative, and the other restriction is that I'm going to have a sum. Their sum, I want it to be equal to negative 20. Okay, so the product of the two is 36. I'm finding factors of 36, starting out with negative 1 and negative 36. The sum of those two is negative 37. That doesn't work. So I try another combination. Other factors, negative 2 and negative 18. Adding those up, I get negative 20. That works. Negative 2 times negative 18 is 36. That checks out. Their sum is negative 20. So this is my correct set of values for m and n. Okay. Find m and n, and then rewrite this as a polynomial with 4 terms. So I started out with this. It's actually minus bx in this case, plus c. And I'm going to rewrite this as ax squared minus mx minus nx plus c. And that is going to, I have an a of 12, so it's 12x squared. M is negative 2. N is negative 18. And C is 3. So now that I have this written as a polynomial in 4 terms, I'm going to solve by grouping. So first, write as a polynomial with 4 terms. 2, use grouping to factor. Factor by grouping. Okay, so remember when you factor by grouping, that's what I'm going to do next. I'm going to group the first 2 terms and the second 2 terms. That gives me 12x squared minus 2x plus negative 18x plus 3. Pull out the greatest common factor. Remember that we discussed factoring by grouping in a previous lesson, so make sure that you have that down. Pulling out the greatest common factor. 12 and 2 have a common factor of 2, and x squared and x have a common factor of x. So that's 6x minus 1. And I can double check that. 2x times 6x is 12x squared. 2x times negative 1 is negative 2x. For the second set of values, I have a greatest common factor of 3, which is going to leave me with a negative 6x plus 1. Now, the next thing I want to do is pull out a common binomial. And I don't quite have that. This is one of those cases where I have 6x minus 1 and I have negative 6x plus 1, so I don't quite have it. However, I would have it if I factored a negative 1 out of this second term. So I'm going to go ahead and rewrite this, factoring out a negative 1. Now I'm going to get rid of that plus, and it's actually going to be negative 3 times 6x minus 1. Now I can pull out the common binomial. And the common binomial is 6x minus 1. So 6x minus 1 times 2x minus 3. Okay, so these do take quite a bit of work, and you need to keep checking back and make sure that you're following each step through without making a mistake. Remember that the first step is to write the trinomial as a polynomial with 4 terms. And you do that by finding m and n. You make an organized list and make sure that m and n fit the criteria shown right here. Once you've got the polynomial with 4 terms, you can go ahead and use grouping to solve. Okay, in this example, I have a trinomial with a leading coefficient other than 1. So I am going to use my usual method where I'm going to rewrite it as a polynomial with 4 terms and then use grouping. However, the first thing I notice is that I have the greatest common factor that I can remove or factor out. So what we're going to do is we're going to see that the numbers have a common factor of 4, and the variables have a common factor of x squared. What's left behind is 12x squared plus 7x minus 4. Okay, so by removing my greatest common factor, I'm left with something that's much easier to work with. And then I'm going to rewrite this in the form ax squared plus mx plus nx plus c. So, in order to do that, I need to determine what m and n are. Well, I have a equals 12. This is actually negative 12 right there. Okay. A equals 12. B equals 7. And C equals negative 12. Okay. Now, to find m and n, what I'm going to do is recall my rules. That m plus n equals b. Here b is 7, so m plus n equals 7. I also know that the product of m and n equals the product of a and c, which equals 12 times negative 12, or negative 144. So working with these two facts, I can write this in this form. Notice also that I have a c that is less than 0, so m and n have opposite signs. And that makes sense, because if m times n are negative 144, they're going to have opposite signs to have a product that is a negative number. All right, so I'm going to start out by finding factors of negative 144. And I'm going to keep in mind that what I want is a sum of m and n. When I sum these two numbers, I want it to equal 7. So these two are going to have opposite signs. So I start out with 8 and negative 18. Adding those, I get negative 10. But remember, one thing I can see is wrong is I want a positive number. So the way to go about it that would be less work is to just use combinations where I have my larger number positive. So when I'm adding the larger positive and the smaller negative, I'll get a positive number. So let's try the reverse here. Instead of 8 and negative 18, I'm going to try negative 8 and 18. But of course, I see that's just going to give me a 10. So that's still incorrect. Okay, next I'm going to try 9 and 16. With 9 and 16, I'm going to make my smaller number negative. I add negative 9 and 16, and I do get a sum of 7. That tells me I found my m and n. I know that I have m equals negative 9, n equals 16. This allows me to rewrite this. Make sure you carry along the greatest common factor, because if you leave that behind, you won't get a correct answer. Okay, I'm going to rewrite this in this form, which is going to give me 4x squared, there's my greatest common factor, times the same ax squared, which is 12x squared, And then I'm going to have a negative 9x plus 16x, and the same c term, which is negative 12. Okay, so I removed my GCF, I put it in this form with the polynomial with 4 terms, and now I'm going to factor by grouping. So I'm going to group my first 2 terms, 12x squared minus 9x, and my second 2 terms, 16x minus 12. Remember, with factoring by grouping, what you're going to do is look at your 2 sets of terms and factor out the greatest common factor. So my greatest common factor for 12x squared and 9x is going to be 3x. So that's going to leave me with 4x minus 3 plus, from here, my greatest common factor is actually 4. So that's going to give me 4 times 4x minus 3. And I look and I see that I do have a common binomial. I'm going to factor that out next. So this is going to give me 4x minus 3 times 3x plus 4. Okay, now that was a lot of steps, so you need to really be careful and double check your work, and you can always double check things by multiplying them back out. So my first step was to first factor out the greatest common factor so that I have smaller numbers to work with. Then I was left with this simpler trinomial with a leading coefficient other than 1. So I went ahead and turned it into this form. I found m is negative 9 and n is 16. I then wrote it as my greatest common factor, 4x squared, times this polynomial. Once I had that, I could solve by factoring by grouping. I grouped my first 2 terms and my second 2 terms, found the greatest common factor for each. Once I got to this step, I saw I had a common binomial factor of 4x minus 3, which I then factored out to get my final answer of the factored form of this original trinomial. Okay. Again, in example 3, I have this form, ax squared plus bx plus c, that general form. Here we have negative signs, which we will take into account. So my a equals 3, b equals negative 6, and c equals negative 4. And I always check before I do any of these steps, I check to make sure that I did not have a greatest common factor. I do not have one with the numbers. I don't have a factor I can factor out from variables. So I'm just going to go on and write this in the form ax squared plus mx plus nx plus c. Recalling that m plus n equals b. So in this case, the sum of these two is negative 6. The product of m and n is the product of a and c. Here, the product of a and c is 3 times negative 4 to give me negative 12. Okay, so both b are less than 0 and c are less than 0. When c is less than 0, m and n have opposite signs. Whether b is positive or b is negative, if c is less than 0, then you've got a product here that's going to be less than 0, and they're going to have opposite signs. M times n gives me negative 12, so they have to have opposite signs. Okay, so I need to find the factors of negative 12. And I want to figure out their sum, and I'm looking for a sum that is going to equal negative 6. If I meet these two conditions, I've found m and n. And I remember that m and n have opposite signs. So I have 1, negative 12, and that's going to give me negative 11. I could try it the other way. That would give me 11. Okay, that didn't work. So I'm going to try 2, negative 2, and 6. That's going to give me 4. I could try 2 and negative 6. That's not getting me anywhere. So I'll try another combination. 4 and negative 3. It's going to give me 1. How about negative 4 and 3? Well, that's negative 1. So I've tried my combinations. I've tried all my permutations that will give me, the product will give me negative 12. And I don't have anything that also has a sum of negative 6. What this tells me is that this is not factorable. I cannot factor this. So what I have here is a prime polynomial. Usually the problems you see are factorable, so you want to be really careful that you haven't made an error before you go ahead and say not factorable. Check through your work first, but sometimes you will find a situation where you cannot factor the polynomial any farther. All right, in example 4, we have an equation. So the first step is to write it in standard form. I can do that by subtracting 12 from both sides. Okay, so now I have an equation in standard form. The second step is to factor it. And then I can use my zero product property to solve. The method we discussed today in order to solve trinomials of this form is to first put them in the form of a polynomial with 4 terms. Let's look at this possibility. Okay, a equals 24, b equals negative 23, and c equals negative 12. Recall that m plus n equals b, so that equals negative 23, and the product of m times n equals the product of a times c. Now, I can already see that if I do 24 times negative 12, it's going to come out to be a very large number. It's going to come out to be negative 288. And making an organized list with factors of that is going to take quite a while, but there is another approach that you can use. And instead of using that intermediary step where you turn this into a polynomial with 4 terms and then grouping that and factoring that, you just go directly to the factoring. So if I think about what I want to end up with, I want to end up with a factored form that looks like this. I know that if I multiply out the first 2 terms, they need to equal 24x squared. So I have something here, and x and x. And these two are going to be factors of 24. I also know that since c is less than 0, these 2 terms, which we've called p and q before, are going to be opposite signs. So these 2 terms right here are going to be opposite signs. All right. The other thing I know is that these second 2 terms, these last 2 terms, their product will be 12. One way to solve this is to go ahead and try different combinations. But how do I know which combination is right? Well, I know that I have to have a combination where I get something here, something here. I know that the first terms, if I use factors of 24, those are going to turn out fine. And the last 2 terms, if I use factors of 12, are going to turn out fine. But the middle term is what I really need to look at. And the middle term is going to have to equal negative 23x. So I'm going to need to try my possibilities. And using FOIL, my first terms, I multiply them, I'll get 24x squared. My outer terms plus my inner terms need to equal negative 23x. And then my last terms, negative 12. So I can check this. I can check my combinations by checking these terms. Now, factors of 24 and factors of 12. All right, so what you're going to do is go through in an organized manner and try the various combinations. And it's sometimes a good idea to just go for the smaller numbers. They're easier to multiply out, so you need to use every combination, but you don't have to necessarily do it in order. This is going to take longer. Let's go for an easier one first. Even dealing with 12 can be a bigger number. So I'm going to go straight to this one, 3 and 8, and I'm going to try it with 2 and 6. So here's my first combination, 3x plus something, and then 8x. Remember, this is going to be a negative, minus another number. My possibilities for here are factors of 12. So I'm going to try 2 and 6. Now, check the middle term. This is 24x, the outer term, negative 18x, and the inner term, plus 16x. That does not equal negative 23x. So that is not the correct combination. Again, I'm sticking with 3x as the first term, and 8x over here. And I'm going to flip these around. I'm going to try 6 here, and I'm going to try 2 over here. Now I'm going to check my middle term. My outer terms, negative 6x, outer, and inner, plus 48x. That's 42. That does not equal negative 23x. Okay, let's continue on with this, but try this possibility next. Again, I'm putting 3x here and 8x here. And I want to keep my signs straight. So I'm going to put 3 here, and I'm going to put 4 over here. Now, I've got my outer terms. So 3x times negative 4 is going to give me negative 12x. My inner terms, it's going to be 3 times 8x. That's going to give me 24x. Again, this is not equal to 23x. Okay? Again, 3x here, and this time I'm going to put my 4 here. $8x minus 3. Now, I've got an outer term of negative 9x and an inner term of plus 32. Well, this is 23x. This is pretty close. The only thing that's wrong is the sign. So what this tells me is that I need to use different signs. I have the right combination, but with the wrong signs. So I'm going to go up here and continue on with my trial and error. Okay, 3x. I'm going to change this to a negative sign. Now I'm going to try it. Now I have 9x. So that's my smaller term, and my larger term is negative 32x. This actually does equal negative 23x. So thinking it out, as well as some trial and error, I was able to generate a shorter list than if I'd used the other method, and to find that the correct combination for factoring is these two. 3x minus 4 times 8x plus 3. Now, I'm not done. This is an equation. These are equal to 0. Remember, the zero product property tells me that if I have a product that equals 0, one of these terms must equal 0. So then I can go ahead and solve 3x minus 4 equals 0. which is going to give me 3x equals 4, and that is x equals 4/3. That's one solution. The other one is 8x plus 3 equals 0. I'm going to go ahead and subtract 3 from both sides, and that's going to give me x equals, by dividing 8, negative 3/8. So now I have my two solutions for this equation, and I worked this out a slightly different way this time, and that was by just realizing that it's going to come out, the factoring is going to come out to this form. I know my signs, and I know that my first terms have a product of 24. My last terms have a product of 12. And the sum of these outer term products and the inner term products is going to be negative 23x. Using some trial and error based on this list, I found the correct combination was 3x minus 4 times 8x plus 3, and then I went ahead and wrote that as an equation in the factored form, and then I solved using my usual methods for solving equations. So that concludes this lesson for Educator.com.